Hey everyone, welcome to our DevOps office hours. It's November 22nd, 2022. This not November 22nd at all. That's what happens when your script is wrong. It is November 2nd, 2022. My name is Eric Osterman, and I'll be leading the conversation. I'm the founder and CEO of Cloud Posse. Cloud Posse is a DevOps accelerator. We help companies conquer AWS using our proven blueprints. If you're starting from scratch, or just not happy with what you have today, then you need to go to cloudposse.com/quiz. Again, cloudposse.com/quiz to book a session with me directly. I'll show you what your future can look like. For those of you new to the call, the format's very informal. My goal is to get your questions answered. So feel free to unmute yourself at any time when you want to jump in and participate. If you're tuning in from our podcast or YouTube channel, you can register for these live and interactive sessions by heading over to cloudposse.com/office hours. Again, that's cloudposse.com/office hours. We host these calls every week. Our call today is recorded. We'll automatically post a recording of this session to our YouTube channel. So if you enjoy the content and want to support what we're up to over here, please hit those like and subscribe buttons. Just go to youtube.com/cloudposse. So with that said, let's jump into some announcements. Pretty light on my plate today, so if you have anything you want to share, cue those up. The first thing is GitHub Actions, which we're a big proponent of using, has added the ability for workflows to now target runners by a set of labels, which is pretty convenient. So the more labels you add to your runners, the easier it is to select where your workflows run. Any questions on that before I move on? All right. The next one is a small little Go utility. I was late to the game. 38,000 people found it before I did. But if you haven't yet found it, then this is cool for you too. If you're doing lots of local development and you also want to be testing TLS locally, it gets kind of annoying when the browser nags that this is an untrusted certificate. So here's a tool that makes it easier for you to generate those. You can provide a simple configuration with the certificates you want to support, and it'll generate it. Of course, be very careful because that root CA is now basically what your computer is trusting for a certificate. So anybody who can inject a new key using that key can be a pretty effective man in the middle. Has anyone already been using this tool or have an alternative suggestion? Oops. All right. The next one is a new Terraform project. I guess they've been at it for about a year. No, not a year. They've been at it for about a month and no updates lately, as are a lot of these projects. I think it was an ambitious project, but didn't have legs. The project, it lets you have a GUI here to construct the resources and set up the mappings, and then it'll spit out your Terraform code for you. I think a lot of these projects are good weekend projects, but I don't know how they'll scale in the long run. And if this is the the way that we want to write our code anyways, but hey, that was Terraforge. All right. Next announcement is we've long had a Terraform module for managing AWS firewalls using Firewall Manager. This is now AWS Network Firewall. We implemented a Terraform module for this last week. So it's in the early stages. If you need it, check it out. All right. Any other announcements that I missed? Something interesting this week? Mike, Managed Chaos. We'll get to your comment on the Pulumi thing right after this in the discussion. All right. Let me also just check Slack quickly here. Any announcements? Doesn't look like it. Okay. Moving on then, let's go right into discussion. So one question by Leonor, are you on? Yep. So before deploying to production and merging into the main branch, how do you test changes made to a service defined in Terraform? So I think there's a little bit added to that question as well in Slack. Let me just open up the full conversation here. I'd be interested in hearing how people approach the developer workflow for services defined in Terraform, in particular, how are changes, hopefully automatically, but perhaps manually, tested before they are merged into the main branch and deployed to production. Terraform validation planning are useful, but don't cover service functionality. I found TerraTest great to test individual small groups of Terraform modules that deploy and undeploy quickly, but I'm wondering how folks approach the higher level end-to-end regression tests in effectively complex services with resources potentially deployed across account. That's a great question. So just to be clear, re-emphasize, we're not talking about the simple case here of kind of like what Cloud Posse is doing in all of our automated tests. For example, if we look at one of these modules like the EKS cluster, what we'll do is we'll have the tests folder in here, and Lionel says, he's very much aware of this strategy, and this is useful for testing like an individual child module, for example. But it gets a little bit more complicated when we're talking about root modules, and especially root modules that maybe span multiple accounts, and possibly even beyond that. Like, what if you have multiple root modules and you want to check the system as a whole? I don't have the answer to it. Technically, TerraTest can still do this, though. TerraTest is really just a test automation framework with some, special hooks to make it easier to work with Terraform. But TerraTest doesn't even need to be used for Terraform. TerraTest is just a good way to do test automation. So how you do that would come then down to your CI platform, for example, GitHub Actions. And I would... Now, the challenge here is, you never have a preview environment capability really with Terraform. What I mean by that is the ability to bring up short-lived AWS accounts even, or multiple root modules is just impractical. So how would you test this maybe in like a static QA environment on your pull request? Before I keep talking, I want to make sure that I'm on the same track, and anybody else have something they want to interject here? Leonor, was there something else you wanted to add?
No, thanks. I think you summarized it really well. Just curious to know how people approach this, and it's obviously you can have like a dev environment, but as soon as you have more than one developer, you're queuing basically. So I'm just curious to know what other people are doing.
Hey, Eric, I want to add to this because someone actually asked me the same question, and I said, oh, yes, use TerraTest. I don't like TerraTest. I don't want to test for outputs. And I was like, well, so you're not talking about integration testing. So, the conversation went into other things, but at the end of the day, what they wanted to do is just to test the code without having to actually rely on an API to do it or apply the changes. So it basically similar to OPA, in that sense, you see, statically, and I don't think that there is a way to get there.
Yeah, I mean, anything can be solved in the world of engineering and lots of money, but I don't think this is definitely something not solved today. You can catch things earlier by adding some linting and stuff, which is also what Leonor said. Like, she's aware of that. Like, you can add these other things, but it's not going to really validate that it's going to work in the target environment or setup. So riffing off of this is a problem that we've had similarly with application testing and deployments. So one of the things we like to do when testing, simple applications, microservices, etc., is, build a container, spin up a ephemeral namespace in Kubernetes, deploy it, and you can validate it to some degree there. But that doesn't solve all cases. First of all, not all applications are easily deployed into ephemeral environments. Sometimes those applications are useless if they don't receive webhooks, maybe from Twilio. How is Twilio going to send those webhooks to this ephemeral environment with a unique name every single time? And it's, the complexity is prohibitive to automate that construction and everything like a Twilio and all those other services. At some point, the Rube Goldberg apparatus has to stop. So the compromise that we've come up for that seems to work pretty well is a concept of QA environments. So let's acknowledge that every organization out there has different terms that mean different things and overload the same terms. So let me define what I mean by that. So in our terminology, we have like a dev account in AWS. The dev account runs pretty much the full stack of things that we would have in staging and production. This is where we would run our ephemeral preview environments, things like Heroku review apps, basically. Then there's what we call the staging account. And the staging account would have, much the same way, would have another Kubernetes cluster or ECS if we're using that, or both. And there would be a discrete staging environment inside of that one account. And that's great when you have one, when you want to test pre-production how the application is functioning. However, there's this other situation where we want to test a pull request in a fully integrated environment that is not staging, because staging in our parlance is the next thing that's going to go live to production. So we want to keep it stable. So that's where we have these QA environments, and those are pets. So they're named. We'll use labels, for example, QA/1, QA/2, QA/3. And that means that we would have 3 static QA environments, and you can have as many as you want. The key is that they're not unlimited and they're discrete. Now you set those up complete with a full stack of everything you would come to expect, including webhook integrations with third parties, should you need them. And then what we do is on our pull request, we set up the automation to look at the label, and based on that label, decide where to deploy that pull request to one of these named pet set environments, so to say. I think the same strategy could work with Terraform. It doesn't work if you don't have like a QA manager or somebody coordinating that. It's definitely out of the scope to come up with a system of locking and unlocking and coordinating all that for most companies, and usually just the word of mouth Slack channels is good enough. Does that make sense? Using static set of QA environments to test pull requests for changes in an integration sense? That was a question for Leonor. Okay, it was a thumbs up.
Yeah. Thanks.
Okay. Anyone else have something else to add to this? And and the last thing to point out here, this is something that I don't think will ever be solved by Terraform itself. Terraform has added some very lightweight test functionality, but it's never intended to replace real integration testing in this sense. And TerraTest having support for libraries and things like that is good. In fact, here's one thing Matt on our team just was working on. We just created a new library. I thought it was called Nuke, something Nuke, but it was a library wrapping AWS Nuke so that you can use AWS Nuke with TerraTest helpers. Yeah, so we created a TerraTest helpers repo. I guess we haven't merged it into main. This is something we're actively working on. But the idea is that from your test automation, you can, let's see here, that was the example itself. Let's go to the work, or rather, where would the, there we go. So here's an example of using this. So now if you're using TerraTest, for example, for test automation, we added this function now that you can call. So you can nuke all the resources in an account by given tag. Because when you do a lot of test automation with Terraform, you will have orphaned resources. So just an example of why we like TerraTest. All right, moving on then, Michael Jenkins, AKA Managed Chaos. Did you bring this up because we had talked about this last week, I think, the declarative Pulumi YAML?
Yeah, I missed last week, but it might have been a week before that. We were talking about Atmos and how it integrates with tools that generate YAML, or it can generate YAML. I'm not an Atmos user, but hearing that talk and then seeing this announcement, I kind of started to see the the gospel, right? You know, so I brought it up as just kind of a point to share, and then you know, just wanted to see who might be. I guess it's a very recent announcement just today, but like if this appeals to people as far as doing infrastructure in YAML. I mean, CloudFormation, it's been YAML since, you know, it started, but from the Pulumi perspective, it's a little bit more general, I guess, in that your YAML is across cloud. I mean, very specific to the resources, but still you're using YAML as an approach to different, you know, clouds, different platforms or whatever. So anyway, yeah, I just wanted to see if there was any interest or discussion around this particular announcement.
Yeah, so I guess just to highlight that this announcement is that it's now general availability. This has been available for at least 6 to 12 months, I believe, in, I guess, a non-GA setting. This is exciting. This is exciting and interesting. I think this is more interesting for me than a lot of people. And that's so Pulumi, for everyone who's not familiar, Pulumi is an alternative to Terraform. More closely, it's an alternative to things like CDK/TF, which is that with Pulumi you get direct language integration with whatever language you are familiar with, whether it's TypeScript, Python, Golang, etc. The benefits with doing that is, of course, you can stick within the language constructs you're familiar with, and you can leverage your debugger potentially to make doing cloud infrastructure easier. It's one less language for your teams to learn, and overall, pretty compelling argument. The challenge for Cloud Posse has been that as an open source company, we want to create reusable infrastructure that we can use across organizations. And while we could do that with Pulumi, we don't want to have to re-implement the libraries in 5 or 7 different languages. So we'd have to pick one, and that's already taking 1% of 1% of users that are doing infrastructure as code, and would not make a lot of business sense. The other problem is that, well, we could write it therefore in any language, and Pulumi is smart enough to be able to read infrastructure provision from any language. But the whole argument of Pulumi is that speak your own language. You don't have to learn a new language. So it doesn't make sense if we wrote everything in Golang and you're a TypeScript shop, you're not gonna want to work with what we've written as much. So this is why declarative is kind of interesting now. Let's say it's a kind of language agnostic way. I say that with some humility because YAML is a markup language. But I guess I'm saying because it's fully declarative and it's because it's in YAML, we're not playing the language war. So it's interesting. But then it gets into exactly what you said, Michael, which is, God, I really don't love programming in YAML. I think it's smart, great. Okay, you figured out a way to do it. CloudFormation was, early on in doing that. But I don't know if that's what we want to be doing. However, if push came to shove because of this, I would say now we have a way of supporting it at Cloud Posse when we want to. because we would probably take the declarative approach nonetheless, because it fits within our model of YAML-based configuration. Anyone else have something to add to this? And yeah, exactly what Pepe said. Atmos is better. All right. That's the end of the questions that I had. I don't see any more questions in the Zoom chat or in the Slack chat. So let's just turn it around. Any questions from the audience?
Hello.
Hey, Gabriel.
Can you hear me?
Yeah, a little bit of background noise.
Sorry. Is it a lot?
No, it's manageable. It's manageable.
Okay. I wanted to say how, like, you have, I guess, more experience than at least me. So regarding this Pulumi and Terraform and YAML and whatever syntax or language, I guess, I mean, for me, the goal would be to make it easier for the developers to be able to, do some infrastructure as code. So, like, because you are so heavy on reusable components and made so many components already, like when someone already made so much of it ready to use, how often does it happen that the developers actually need to write new components? Like, you know what I mean?
That's a good point. Well, that is our goal. So our goal as a business is trying to find as many of those reusable building blocks as possible, so that the need for developers to almost do anything is unnecessary. The customer journey that we see with our customers is that we get them on the rails, delivering the baseline of components that we have for 98% of the things that they need. They go on and add components for the missing pieces. And then what we see happen is, after a few months, they start, totally embracing this wholeheartedly, and then start adding in new components for different features or capabilities. And one of these customers, I think they're up to almost 1,000 different components now, and that might be a little bit overkill, but it's a practical model to scale, I think. Why I like this more than just giving developers directly the code itself to work with, is not a bad model, but it's a difficult to maintain model, because we want to reduce the amount of times a VPC has been defined in code. Like, we want that to be defined in configuration more, right? We want to, S3 buckets and all these other things fit that same category. So the more that we can pigeonhole what we want to build in terms of an architecture into the buckets that we have, into these components that we have, the more maintainable it is, rather than if we had to update 15 projects and how they use S3 buckets. That's a real pain in the butt. For example, when Amazon's V3 AWS provider came out and broke S3 buckets, that was really painful if you were manually defining S3 buckets everywhere. Manually being in Terraform code, like raw resources. Yeah, and this is a philosophical thing for us. How, like, if we were doing this in Pulumi, we would do a pretty similar approach. I think we would still come up with the building block pieces written within Pulumi modules, whatever they call them, and expose still a declarative YAML configuration, so that in the end we're very prescriptive about how it's implemented, and the end user is just responsible for flipping feature flags.
for what it's worth, I agree. Yes.
Okay.
Yes.
Well, it's.
I mean, like
That's good.
just like you know, I mean, just like 5 or 10 or whatever amount of people, all of them, somebody writing in JavaScript, somebody writing in this, somebody writing in that, everybody writing their own. I mean, I cannot imagine the chaos. I don't know. I mean, yeah.
And this is a principle that we've extended now, like to even GitHub Actions. I really, what I hate is when you see an organization that has, you know, hundreds of repositories, kind of like what we do, but every repository is defining its own workflows from scratch with its own actions and its own steps. It's unmaintainable. So this is why what we love is with GitHub Actions, you can do the same thing that we've done with GitHub modules, is create these opinionated implementations of how to do things. So we've recently created a GitHub action for spacelift deployments, for example, here I'm just looking at. And this one hasn't been merged, right? Or this one, the documentation is still pending rather. So it's a bad example. But the idea is that with GitHub Actions, you can test every individual action you write with its own workflows. So test-driven development on your GitHub Actions themselves. And then you can define the GitHub action itself, which it would be in the root of this here in an action. And you see what we're using here is we're leveraging lots of other GitHub actions. So we're not reinventing the wheel. We're leveraging spacelift's action to install spacelift. We're leveraging some other JQ action. And then here's our actual implementation here. And this is a composite action. So I think therefore anybody doing release engineering today using GitHub should be following a similar approach to modules with actions. And then you just define a YAML interface to it. All right, any other questions about this or anything? One random thing was, so last week we talked about home automation with Home Assistant. There was some interest on that. So we created a new channel in sweetops. It's called Home Automation. So if you're interested in continuing that conversation, join the Home Automation channel in the sweetops Slack.
Okay, since nobody is asking anything, maybe I can try.
Yeah, go for it.
How can I say, like, did anybody experience some intermittent 502 errors with Kubernetes? Not a lot. Sometimes they happen, the 502 errors. And how does anybody have ideas like how to debug it? So what I did,
or just to clarify, are we talking 502 errors to the Kubernetes API or 502 errors
sorry.
service behind a service?
Service behind service. Yeah. So one thing that I did that reduced the amount of the errors like quite a lot was to implement proper graceful shutdowns of one particular application, because that helped. But I cannot get, like, I still didn't manage to get completely rid of the 502s. So,
do you know what they were associated with? Are they associated with pod scaling, node scaling? Are you, what load balancer are you using? I mean, what ingress are you using?
Yes. So I use a Ingress Nginx controller. Like,
okay, yeah.
And I use the standard, like AWS node daemon set IE network interface, and proxy kubeproxy. And
where are you running? Are you running on AWS or
EKS? AWS EKS, yes.
Any reason you're using the Nginx ingress controller as opposed to the ALB controller?
Couldn't tell you. Couldn't.
So one of the things to think about when you're running ingress Nginx is that ingress Nginx is the community supported ingress controller for Kubernetes. And the way it works is every time any pod anywhere in the cluster is launched and added to any ingress whatsoever, Kubernetes will reload ingress, will reload Nginx, basically. A new Nginx process will be launched and then take over the socket and continue. So if you have a busy cluster with lots of pods joining and leaving, Kubernetes is, oh, sorry, Nginx is constantly getting reloaded, basically, which kind of sucks. The good thing, though, if you're using ingress Nginx, is that you have the full power of Kubernetes, oh, sorry, of Nginx at your disposal, and you should be able to probably modify the it so that it can retry or restart requests. So a failed request could possibly be restarted and sent to another pod, and it might work. Obviously, that introduces this potential of request storms that could cause as much harm as they can, save you from 502s. These 502s, who's impacted by them?
It's users. It's users of and to be honest, the problem is not with the ingress. The problem, so what it actually looks like is the ingress sends forwards the requests to a service, then to another Nginx, and then this Nginx forwards the request yet again to another service backend application. So there's ingress Nginx, and one more Nginx, and then an application, and where the errors happen is on this second level between a backend and an Nginx. That's where the and what's also interesting is
what is the backend? Okay, so for the second tier of Nginx, what is the backend? Is it like a Rails app or Django? Or
it's PHP.
It's a PHP app. Okay, so in this case, what's probably happening is every PHP worker is busy, and therefore there's no more workers to handle that request.
Yes, yes, man, you know your way around. No, I also tackled that issue, and so there is like 10 workers, and then there is a queue, because you can configure a queue. And so if you have more than 10 requests, then the others go in a queue. And what I did is, for example, that was also like that made the probes fail because the container might be busy at the moment. Some requests might be in a queue, and that was causing the probes to fail, which it should not. Like, just let it work if the queue is busy, like if they are it's busy. And that's what I implemented some logic into the probes, so that it checks for the queue, and if there are things in the queue, then skip the probe, and I added some timeout. So I did that too. So because if the liveness probe fails, for example, 3 times or whatever times, then it restarts the container, which also might cause interruptions and 502 errors. So I did that. What I'm interested in, to be honest, also like could it be an issue with the Kubernetes networking itself, like with the service or with these services, and how would I debug that? How would I confirm, is it a networking issue? Like, that's also.
I think, I mean, you maybe will be able to glean some information from kubectl in that case, but
Yeah.
Yeah, what's your monitoring platform?
Datadog.
Datadog, yeah.
Datadog.
I don't know. I think you've assessed the root problem. That sounds pretty, that sounds familiar to me and run into that in the past. I'm scratching my head here because I feel like we solved this and there's some way, basically you want Kubernetes to stop sending requests to that, or you want Nginx to stop sending requests to that upstream when that upstream is fully busy.
So
then,
no, like exactly, like that's the root problem of all. Like that the root problem, one of the root problems, like maybe the root problem, I don't know, is that the load balancer does not know about PHP workers or PHP queues, or and it's not balancing based on that. It's just doing a round robin.
Anyone have some suggestions?
So that's why I would like so also it's interesting sometimes quite often it happens that the 502s pop up when the pods are scaling up. That's interesting also. And yeah. So but then that's the readiness probe. So the readiness probe says the container is ready, then it should be able to receive requests. But yeah, it's weird, it's interesting. Like I'm considering but I would like to verify, but it's not that easy. I will continue trying, but because of all these things, I'm not sure. And but I'm considering switching from kubectl and to Cilium. This Cilium. Cilium, like eBPF, like that.
Yeah, eBPF, it's an alternative. And with that, I believe you can get end-to-end TLS within the cluster as well. So, I mean, that would be the other reason to do it.
It's okay, but
I feel like this should be a solved problem, but I don't remember how we solved it.
It's fine. It's fine. It's good. I mean, it's good. At least it's not an obvious problem, obvious solution.
Anyone else have some challenges or questions or suggestions?
I have a question. We're fairly early in our DevOps journey, but we're using Atmos and your components to build our infrastructure. And I'm hoping to get. We're not there yet. We're using EKS and Helm, and we're not quite at Gitops yet. Looking at something like Argo. But one thing we are doing, at least, is automating our environments up and down on a schedule, because we're actually moving our PeopleSoft to AWS in containers, and so there's RDS Oracle databases that we don't want to be incurring costs in our dev, TSD UAT environments. And so I'm kind of curious, looking forward, I'm just using a GitHub action right now that has like OIDC rights into the account to shut down on a schedule. How do you, looking forward at a GitOps way of doing it, it seemed like a lot of commit changes to a repo to be scheduling it up and down. How do you solve that sort of problem?
Well, okay, so what you would probably want to do is do a few things here. So one is we are working on at Cloud Posse introducing, oh no, mosquito. Oh, we are working on our GitHub Actions for Atmos as well. We're doing this as part of another large engagement, and all of that will be open source, but that probably won't be until towards the end of the year. The way I would approach what you're doing, first of all, I think it's cool. And let me make sure let me reiterate it to make sure I capture what you said and understand it. So you have defined using Atmos, for example, a complete stack that you want to bring up and down. That stack is running PeopleSoft with a bunch of other database dependencies. Now, on a regular basis, do you want to bring up and tear down that stack completely to validate that it's working? In addition to every time something changes in the stack, you want to validate that it still works. Is that an accurate representation?
Fairly. I don't know whether we were going quite that far. It was more as a cost optimization, not running databases through the evening, basically emptying the cluster and stopping RDS, was the approach, and so if the cluster is controlled by a Gitops operator, Well, so in a GitHub Actions sense, you do still have, and I forget the term they call it, but the equivalent of scheduled runs. So you can run. Which is what we're doing. Yes.
Oh, okay, perfect. So then I would have one workflow that brings it up, and then I would have another workflow that tears it down, and a third workflow that just goes out and nukes everything just in case something failed or was lost. So that's pretty straightforward there. One of the nice things you can do is setting the I forget the parameter, but in the AWS provider you can set the mandatory tags or required tags, and that way even if some resource was provisioned without null label and without using our argument of doing all that, it'll still at least be appropriately tagged so that you can identify orphaned resources. If you are, bringing up a lot of Kubernetes clusters, for example, we ran into this issue with our test automation for EKS. I believe some log groups are orphaned. Maybe that's been closed now. Oh yeah, this was the one issue I was thinking of, and maybe this has been resolved. Anyways, the gist of it was that when you're provisioning a lot of this infrastructure programmatically, there can be things you'll run into these kinds of errors where resources won't have fully destroyed yet or will be orphaned. So yeah, that's all I have to add to that. Oh, are you familiar with the workflows in Atmos?
Yes. Yes.
Okay. So we just merged a pull request yesterday for those that enhances their capabilities, and that might help. So one of the things we show here is how you can reference basically all the variables within the steps.
Oh, cool. But if I understood correctly, Charles also mentioned like a Gitops way of tearing down and like it doesn't make sense to constantly like on a schedule like make changes in version control.
Personally, I don't like it. I would not like to have programmatic to bring it up and down. I think I don't know, maybe I have a more liberal interpretation of GitOps in this sense. So if we think about it like from not Argo, Flux. So Flux, they have a nice explanation of GitOps, and that it's like this change firewall, and that this firewall must represent the state of everything, and in order to change anything you must make the change on the firewall, and in this case the firewall is your version control system. So if that's the definition, what you said is totally right. Like, yeah, programmatic commits all day long, changing the state of what you want. And if you were using Argo CD, well, that's what you got to do. but you are not using Argo CD. You are using GitHub Actions, and GitHub Actions has this concept of a cron. And to me, what I don't see the problem. That cron is managed with code. That in order to change how that behavior happens, you have to make a pull request to change that behavior. That is a Git operation. That operation is running fully unattended and automated by the GitHub Actions. To me, that still satisfies my expectations of how it should work. Open to dissenting opinions, by the way. I can speak sometimes a little bit authoritatively, but I want to hear other opinions.
I would say also, I agree. And I also, I also have a cron, like I don't have it in GitHub Actions. For this purpose, we have another custom tool that we built, and developers can set this cron for their environments, stagings and development environments, and they can set like up and down, like when they want it to go down and when they want it to go up. And basically what it's done, or what happens is I scale all, for example, deployments to 0. I scale all stateful sets, etc., all cron jobs get suspended, and that's basically what I do.
Yeah, and a lot of that is a little easier almost if you are using Kubernetes. So, all right. Any other questions for the group here? I don't know if this is too embarrassing to call out, but I do think it's pretty cool. Hugo Samoya III is the son of one of the guys over at Cloud Posse here, and he's just taken his, I believe, Terraform exams, his CKA exams for becoming a Kubernetes administrator. And I think it's just pretty cool that we're at this point where generations are using the tools that we build.
Yeah, it's nice to meet you. My dad told me a lot, so I wanted to join.
Yeah, welcome. All right. Well, last call for questions. Otherwise, we maybe wrap things up a little earlier today.
There was one in the chat, I think.
Oh, just checking here. I'd really like to understand the concept of the context.tf I see in all the modules. I came across it oftentimes, but struggle to understand how it completely works, or better, how it's wired up. So let me see here. Martin, first question I have for you. Are you familiar with Perl or JavaScript? What happened there? So the idea here, and let's see here. I don't. Is Martin still on the call? I don't see him on my list here. But yeah. Anyway, so the key thing here is that in a lot of languages, they simulate object-oriented programming by passing an object around like this, or your context. So you don't have to keep repeating yourself to every function that you want to call. So you'll pass this context around when you initialize, and then maybe when you get product, and then when you set product, and so forth. What we found ourselves doing at Cloud Posse in our modules had the same problem, is that when you use a lot of modules, let's see, especially modules that call other modules. A good example would be probably in our components. And let's look at ACM. So we have all these variables laying around, and if we had to pass those around every single time, it gets tedious. If we go look at context, I got it. Yes. Die, mosquito. All right. So here's an example where we want to make sure everything we provision in AWS has a consistent name. We don't want the end user to name things because we all acknowledge that naming things is very hard. So the fewer things we can ask of the user to name, the higher the chance we're going to be consistent and we're going to have a unique name. So we've been opinionated about this, and we're going to be releasing code over the next year that's going to allow for a total variability here. And you don't have to use our naming convention, but this is what we have today. So we have this thing called a namespace and a tenant and environment and stage and name and attributes and so forth. And we have these in every one of our modules so that we can have a consistent name in every one of our modules. And so that we can invoke our modules any number of times without even knowing how many we're ever going to need to do. So you might have 10 VPCs or you might have 1 VPC. You might have 10 clusters or you'll have 3 clusters, etc. And what you will find when you look at 99% of Terraform modules out there that do not use our null label module or do not follow the context pattern is that they are inconsistent in how resources are named. Usually there'll be one parameter, it'll be name. It'll accept a name of some kind. So, okay, I'm the user, I'm gonna call this, I'm just gonna call it VPC. I forget that I'm gonna be in multiple regions. I forget that I'm gonna be in multiple accounts and all these other things. And then every time the author of that module wants to create another resource in the module, they'll just use string concatenation and they'll just like add like name dash, yeah, I don't know, name dash bucket, name dash security group or something. And that kind of works. But first of all, your resources in AWS, and when you look at the tags, are going to be all over the place, very inconsistent. And if you're meticulous like we are, we just want to look at AWS, we want a consistent convention absolutely everywhere. So what we did was we implemented, first we implemented Terraform null label. And null label allows us, is a very, conceptually very simple. It's kind of complicated just because of Terraform, but it's conceptually very simple is that when you call it, you pass it a bunch of settings and it's going to generate an ID for you that's consistent everywhere. But you're going to have a lot of labels in your modules. You're going to have a label for the security group. You're going to have a label for your IAM policies. You're going to have a label for your bucket. You're going to have a label for, I don't know, for your EKS cluster and load balancer and target groups. All these things need labels. And the wrong thing to do is just append things with a blindly using string concatenation. The right thing to do is have a naming convention, and that's what we've done here. But imagine if you had to pass this 50 times, 20 times, 10 times, whatever in one of your modules, that gets old real fast. And that's what we were doing for the first 3 years or 4 years of using this module. It got really repetitive. So as the Terraform language got more sophisticated, opportunities opened up. So what we did was, hey, why don't we just pass a map around? And that's going to be the context. And then when you want to override settings, you can just set them here. So that's what you'll see what we do. And like, I think it's in our, another example would be in our subnet module. So we want to provision a NAT gateway. We want to generate a new label for NAT. All we know is it's going to do NAT things. I don't need to know anything else. So I'm going to pass it my current context. So it knows what account I'm in, what region I'm in, what environment, what, tags, all of that stuff gets inherited. And then we're going to add this attribute that, hey, oh yeah, we're a NAT. and that gets intelligently concatenated in the end, but following an enforceable convention. So that's what we get with the context.tf pattern. So we call this file a mixin. We call it a mixin because it adds functionality and it's just copied into your projects. You just copy this file in and you get all of this functionality for free. Now it's up to your code to use the mixin. So you refer to module.this and any of the parameters. So Martin, did that help answer anything? Any new questions as a result of that? The simplest example of this would be in our Terraform AWS Terraform example module, by the way. So this is just a boilerplate Terraform module that serves as our template. We use this internally at Cloud Posse. Every time we create a new module, we just use this as a template. And that way our modules are consistent. But this implements a very simple example of a well-designed Terraform module. And it has the context.tf, and you can play around with how we use it in main and in outputs. Cool. Well, it sounds like that answered the question. Thank you, Martin, for bringing that up. We are at time, so I'm going to wrap things up for today. Just want to remind everyone, please do subscribe if you haven't already to our YouTube channel. It helps us out a great deal. Just go to youtube.com/cloudposse and subscribe. Reasons to subscribe: we post all of our back catalog of office hours episodes. It's searchable. You can find talks that we've done on pretty much any topic. We've done these calls for 3 years, every single week, without fail. I strongly believe in don't break the chain. If you haven't connected with me yet, go to linkedin.com/in/Osterman. Again, linkedin.com/in/Osterman. If you're based in the US and you have extensive experience working with Terraform, Kubernetes, and AWS, we are hiring at Cloud Posse, so please reach out to us and let us know. And if you are interested in getting our digest of interesting links every week into your inbox, just go to newsletter.cloudposse.com and subscribe. We send out a newsletter every week with all the cool links that we find. And our Slack community, slack.cloudposse.com. You'll find over 6,000 helpful members, all speak in Terraform, Kubernetes, AWS. Super helpful and where I learned so much. So thanks everyone for your time. We'll see you all next week, same place, same time.